Welcome to our video for the fifth concept in chapter 5. We're going to be graphing linear inequalities on a coordinate plane this time. So the difference between a regular inequality and a linear inequality is that linear inequalities have two variables. So remember when we did our chapter over linear equations and we had to graph them? The most popular form of a linear equation that we dealt with was the slope-intercept form. Remember slope-intercept form? Y equals mx plus b, where the b was slope. I'm sorry, m was slope, and b was y-intercept. Okay, so that meant if m is slope, it was a number, and b is the y-intercept, it was a number. We had two variables. We had y and x, which always remained variables, and they were never any kind of number in that place, okay? So in this section, we're going to be talking about linear inequalities. So as you guessed it, they're going to take on this form, and they're going to look almost identical to an equation in slope-intercept form, and you're actually going to graph them the same way you did when they were in slope-intercept form. It's just that the only difference is that instead of an equal sign, we're using the inequality signs. All right, so we'll get there. Let's go over this real quick. Let's remember how to graph an inequality. Let's review. So when we're graphing inequalities, we're going to graph them the same way that we did with linear functions. So when we had an equation in in slope-intercept form, we would plot the y-intercept. So we'd find b and plot that number on the y-axis, and then we'd follow the slope in order to get to our next point and plot it. And then if we wanted a third point, we could follow our slope again and plot that point, and then just connect the points with a straight edge. Pretty easy, right? So in this section, you're going to do the same thing. Let's review. In this example, y equals mx plus b. What is our y-intercept? We need to plot it. That's going to be 4. That's our b. So on the y-axis, we're going to plot at 4. And by the way, I know this graph copied really lightly. I'm sorry. We'll do our best. And our slope is negative 2/3. So if it's negative, that means we go down 2 and always to the right, still to the right. The negative just means down or up. All right. So down 2, 1, 2, and to the right 3. 1, 2, 3. Good enough for me? And I don't know. Let's do another one. Down 2 more. 1, 2, and to the right 3. 1, 2, 3. All right, so this is the graph of our line. Okay, see how easy that was? So this time we're going to do the same thing. All right, so like I told you, the only difference is that instead of this equals, we're going to be using the inequality symbols. And another little difference is in what our line looks like. All right, so remember when we were graphing them on a number line, and whenever we had the less than or greater than signs, the ones without a line underneath them, we used an open circle like this. Similar to that, when we're graphing them on a coordinate plane, we're going to use a dashed line. Okay. So instead of the solid line like this, we're going to make it dashed. And then if you remember when we were graphing less than or equal to or greater than or equal to on a number line, we used a closed circle like this. So kind of similar to that, when we're graphing on a coordinate plane, we're going to use a solid, S-O-L-I-D, solid line. Miss Rebecca can't spell today. Okay? And then last but not least, remember when we were on a number line, we had to draw an arrow kind of shading in all of the numbers that were a solution. Well, we're going to kind of do the same thing. So if you're using less than, you're going to shade in all the numbers below. If you're using greater than, you're going to shade in all the numbers above your line. Okay, so number 41. We're going to graph this the same way we would if it were a linear equation, And then we'll look back and talk about, should we have a solid line, should we have a dashed line, which part of the graph should we shade, et cetera, okay? So looking at it the way it is, this should be really easy for us to graph. We need to find our y-intercept, which is b, -1. So on the y-axis at -1, we have a point, and then our slope is -2, kind of like -2 over 1. So we need to go down 2 over 1, down 2 over 1, et cetera. So going from this point, down 2 over 1, down 2 more over 1. I think 3 points is enough for us to graph. Now, before we draw any lines, let's look at our symbol. We have the greater than symbol. This isn't greater than or equal to. It doesn't have the line underneath it. So let's look up here. We need to use a dashed line. Okay? So when we're graphing, connect with a straight edge, use a dashed line. So, like that. Perfect. All right. So now let's think about which side of the graph we should shade. So we have greater than this solution. So we need all the numbers bigger than. Well, we can do one of two things. We can look at this graph and go, okay, well, it's sloping downwards and all the bigger numbers are going to be shaded up on top of it. And that's great. Another way that you can test this is to pick an ordered pair and see if it's a solution. So let's see, we've got kind of two halves of this coordinate plane. It's kind of cut into two halves by this line. So let's pick a point on this side, and let's pick a relatively easy one so that the math is easy. And see how the origin, if I zoom in here, the origin is on this side, 0, 0. And plugging in 0 and 0 for x and y will make the math really easy and really easy, quick to check. So let's use the origin. Let's use 0, 0 and see if it's a solution. If it is, we know we can shade in the top part. So if we plug in 0, 0 into our equation, y greater than -2x minus 1. So let's plug that in. 0 is 0 greater than -2 times 0 minus 1? I don't know. What's -2 times 0? 0. And then what's 0 minus 1? -1. So is 0 greater than -1? It sure the heck is. All right. So we know that we can shade in the graph up, or the space of the graph that's above the line. So it's going to look like this. I'm just going to use my red pen. And it doesn't have to be perfect or pretty or anything like that. Just shade it like this. Just take a pen and scribble. Good enough. All right. So 42, we're going to do the same thing. We need to graph our y-intercept and then follow our slope. So our y-intercept is at -2. And the slope is -4 over 5, so down 4 over 5. 1, 2, 3, 4, and over 5, about right there. Okay. Now I could plot another point, but I'm going to run off my graph. And I could actually plot it the other way, so I could go up 4 and to the left 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. About right there. Okay. Now before I connect these dots, let me look at my symbol. It's less than, so we need a dashed line again. Okay. All right. So let's look at our symbol and see. We've got all the numbers less than this equation. So if we're talking less than, in my mind, that means we need to shade below the graph. A quick way for us to check, once again, is to pick a point and see if it works. Even though the origin is on the side that we don't want to shade, you can still use the origin to check, because if we plug in 0 and 0 again and it doesn't work, then we know we can't shade the top part, we got to shade the bottom, which is what we're thinking anyway. So let's use 0, 0 and plug it in. 0 less than -4/5 times 0. Anything times 0 makes this 0. So 0 minus 2. So is 0 less than -2? No, it's not. 0 is greater than -2. All right. So we know that we can't shade the part that includes our origin, because that's not an answer to this linear inequality. So yeah, we were right. We have to shade down below. All right. Let's flip over to the back. So I'm going to skip 43 and 44. I want you to circle them right now. 43 and 44 look like the first two on the front page, and they're really easy to graph. You'll plot your y-intercept and just follow your slope. But I want to start looking at the rest of the problems, starting at number 45 and then on. These don't look like they're in slope-intercept form. These are in standard form. But we know how to graph in standard form. For me personally, I like the hideaway method. I think it's quick. I think it's easy. If you want to solve this and put it into slope-intercept form, you are more than welcome to, and you already know how, so I am not going to show you how to do that. I've already showed you. You can go back and look at the videos from chapter 4 if you want to remember how. 46. Let's go over here. This one, looking at the numbers, this is going to be really easy to do using the hideaway method. So real quick. Let's hide the y stuff. We get x is greater than or equal to -4. So we're at x. And we're, at -4, I'm sorry. Make a point at -4. And to solve for y, we have 4y is greater than or equal to -4. Divide by 4, and you get y is greater than or equal to -1. So -1 on the y-axis. All right. Now, how do we know if we should use a solid line, a dashed line? Well, this is a greater than or equal to sign, so that makes a solid line. Okay, so that makes a solid line. And then as far as what we should graph, well, this is pointing all the numbers greater than or equal to, so that means all the numbers above. Once again, if you would like to check your math, you can. So let's plug in our origin, see how the origin is within the shade or the area that we want to shade. So let's plug that in. 0 plus 4 times 0 is going to be 0. And then is that greater than or equal to -4? Yeah, 0 is greater than 4. Or, I'm sorry, 0 is greater than -4. So that worked out, and we know that we can go ahead and shade in the top half of this. Okay. All right, guys. On 47, when you hide the y and you solve for x, you get x is greater than 3. So on the x-axis, you'll have 3. But pay attention to y. We'll divide by the -3, and you'll get y is greater than, well, actually, you get y is less than -4. So -4 on the y-axis. Okay. It is a greater than symbol, so you'll use a dashed line. Okay. When we subtract 4x to the other side, we get -4x plus 12. But then we've got to divide by this -3 so that we can solve for y. And when we divide by a negative, what happens is this sign flips around. So you'll have y is less than or equal to whatever the equation comes out to be. All we really care about is how the sign looks, so we know which part to shade. And since we're talking less than, I'm going to assume that we need to shade below. But the origin is part of the graph we don't want shaded, so let's check and make sure if it works out. 4 times 0 minus 3 times 0, it's all 0. So is 0 greater than 12? No, it's not. So the top of the graph where the origin is, that's not the solution. So yes, I was right. I do know that I need to shade into the bottom. All right, so 48 will work with the hideaway method, so go ahead and try with the hideaway method, and don't forget about 43 and 44. I also left those for you. So you have 3 of them to finish. Do your summary questions. Have a good night. See you guys tomorrow.